we'll go to the person in the third row, please. Thank you. Tsudo from Citigroup Securities. I would like to ask a very unelegant question. When you consider the enterprise value of NTT, what contribution do you think are you making? Investors would like, so from the standpoint of investors, let me ask this question. So you talk about academic output, patents like patents and other intellectual property, or the number of citations, and also where you are in terms of computing technology. Can you comment on those issues, please? Thank you very much. Well, we are focused on the next generation information processing technology. So from that standpoint, quantum computing and neuromorphic computing, these two are the representative candidates. Now, as for the former, we accept acceleration of calculation, and the latter will lower the power consumption. These are the strong points. So these two technologies, in relation to IBM, Google, and Microsoft, these technologies, I believe, these would represent the competition for NTT as far as these technologies are concerned. Now, one of the features of NTT is that when it comes to quantum computing technology and also neuromorphic computing technology, they're not very distant from each other. So if you use optical technology, especially optical telecommunication technology, within one calculation, you're able to have them side by side. You can do this simultaneously. That is our thinking. So I simply focus, so if there's one message that we should take away, quantum computing and neuromorphic computing by using optic technology can be coexist side by side in one single device. That's the one takeaway I hope that you'll take back with you from this presentation. So I think NTT, in the fact that it's already addressing this technology, is running a very unique course. But it is not directly, we do not have direct competition in this arena. Thank you. Have I responded to your question? Point taken. Thank you. One other question. So in terms of the personnel at NTT Physics and Informatics Laboratories, you're competing with, what is the situation pertaining to your competition like Microsoft and Google, for example? Well, when we take a look at the past 10 years, and we take a look at the research community over the past 10 years or so, the likes of Google and Microsoft and Intel, what they have done is to attract they have actually acquired the most outstanding research teams in universities, and they have incorporated that into their own corporate structure. So up until that point in time, research was pursued by the academia, but now the R&D center has shifted to the corporate sector. The gravity has shifted to the corporate sector. So knowledge and technology are now, if you will, locked in by these companies. That has been the trend for the past 5 or 10 years. Now, what about NTT? R&D in this area, we believe that it's a very long-standing, it's going to be a very protracted type of an activity. So this entails, it's important that we have a win-win relationship between the industry and the academia. It's important that as a pipeline, we engender the next generation of students and incorporate them into the corporate community. So we need to have something that benefits the corporate sector. We also need to have something that benefits the university sector. So I believe that type of collaboration and cooperation should be structured. That is our thinking. And that translates into the open network, the open research structure that we talked about. We're not going to incorporate everything under the sun under NTT. Some ideas will be held by the universities, but we want to incorporate that into our activities. So academia and industry, they should leverage their own unique strength and work toward these same common goals. So the very final picture on this page. This is what we want to achieve. So maybe this differentiates us from the other companies.
Thank you. Yes, well, the person in the fourth row from the front. Yes. Kinoshita from Merrill Lynch. And I think I have just one question, and scalability and the bottleneck. Well, what would be the things, a bottleneck which should be solved to make it larger? And then if this goes on at this speed, and then computational optimization problem, and then, well, what time? When would be on the time when this would be just actually put into the actual or practical application? And 100,000 bit and 10 billion synapses, and that's where we are now. And 1 million bit or 10 million bit, or and then we have to really increase any number of the neurons up to 10 million. And if we are to really scale it up, and the fiber length should be extended, and also we really have to have the repeated pulse sending, and the optical parametric oscillator, and then optical technology further needs to be upgraded in terms of stability and in terms of device stability, and particularly and the oscillation threshold should be reduced by several digits. And then we are now beginning to see some very promising technology to enable that, so we can paint a rosy picture. And that's one important factor. And measurement feedback based system, and neuron coupling or connection in FPGA, and that is digital device. And what the degree of the circulation, and also the clock related, the circuit related technology needs to, or the digital technology needs to be further improved. And here again, we see a very rapid progress, and every 2 years, the performance has significantly been improved, and also for both of them, to a certain degree, we do see a very promising sort of technology in a vision. And so I think for the time being, we will be able to really make a progress with these the technologies. Now, the machines to really solve the combinatory optimization problem, and when would that be really practical? And at this point, we don't know. We have no idea. Basic research labs, all this knowledge needed for marketing, and vis-a-vis the competitive technology, and with the performance of the computer will be the very enough to really compete. And of course, you have to really think about the prices and the size. And unless we solve all these, we will not be able to really have the demonstration done in society. And to be very candid with you at this point, there are so many unknown factors. And the reason for establishing this particular lab, and even though we don't have all the knowledges, we would like to really identify each of them, and where do we have weaknesses, and we would like to really discover that and find that as soon as possible, and to come up with the solutions to address all this. Additionally, and the promising technology is really being coming into view, and FPGA and optical related technology, and so that is the promising technology being developed by the NTT, the basic research lab, or from somebody else. the heart of the QNN. And the very new breakthrough is coming from the Harvard University, and then it has been made into a practical machine by the Stanford University, and it's not really introduced into Japan, but major focus is placed on this. And FPGA-wise, as you are well aware, and you have that main body in the United States, and what's being developed in the United States are going to be used. Unfortunately, as with those two items, we have not been able to really have this sort of established the technology which would be world leading in our NTT labs. We are running behind the schedule, and Dr. Yamamoto is going to join us in that networking session in the second part. So I hope that you will avail yourselves of that opportunity later. And so we now would like to really conclude the second presentation. Thank you.